Good morning, everyone. So, we are going to start our second webinar today. This webinar will be on the present demand of artificial intelligence and deep learning. So, now we have our presenter, Dr. Suraj Prakash Sahoo, who is currently Assistant Professor of CBIT Hyderabad. He has completed his master's degree and PhD degree from NIT Rourkela, and his research interests are computer vision, machine learning, deep learning. So now I welcome Dr. Suraj Prakash Sahu to present his webinar on this topic.
Thank you. Thank you, Sri Sindhu. So you have reduced my burden to introduce myself. So straight I can start the presentation. And before starting, am I audible clearly and visible?
Yes, sir. You are audible, sir.
Okay. So I think throughout this presentation I can switch off my video. So after the presentation I can start it again.
Okay, sir. No issues.
Just 1 second. Is it visible now? My
Yes,
screen.
sir. It is getting visible, sir. Full
Okay.
screen. Make it full screen, sir.
Now I have done it full screen.
Yes, sir.
Coming.
Yes, sir.
Okay. So this session is being recorded. Am I right?
Yes, sir.
Okay, just to remind you whether you have forgotten.
No, sir. Yes, sir.
So let us start today's discussion. The topic is present demand of AI, and in that we are going to see some parts of deep learning. So that will be the topic. So why I have chosen this topic? There is a reason behind it because now I am teaching to my students the subject artificial intelligence, and when I am going to class and I am asking them why you have chosen this subject. The subject name is Principle and Applications of AI. Simply, they are telling the demand is there. Yeah, in the market now. Artificial intelligence is a demanded subject. So by studying this subject we can get some help for our job recruitments. So but after that, my first question is, what is AI, and why in market suddenly the demand of AI has increased? So if that question will come forward, then the answer will be, means there will be no answer. Simply they will tell that this artificial intelligence came just recently, just 6 to 10 years back, and it grabbed the market. So whenever we are talking like artificial intelligence came into the picture or it has become famous just before 6 to 10 years, the scenario is not like that. The artificial intelligence was with us till now, and the story of artificial intelligence is not recent. It is a story of around 70 years. So that is why I have chosen to introduce this subject to the audience so that we can able to answer the question what is artificial intelligence and why there is a big demand in the market. And the second thing is why I have chosen this subject, since we are from technical background and now our older generations like my parents, your friend parents, everybody is they are using internet up to larger extent. So whenever they are seeing these terms, what is cryptography, what is artificial intelligence, so they will start asking. So when they will start asking, we have to be able to answer them. So that is also one reason why I have chosen this subject. So before discussing about artificial intelligence, we should know when it has started. So officially, this field or this term, artificial intelligence, is being uh, is defined or is given by four scientists in the year 1956. So we can say officially in 1956, the artificial intelligence term is born. So that is why these four scientists, John McCarthy, then Simon, Newell, and Minsky, these four people, they are known as the founding fathers of artificial intelligence. So in 1956, what has happened? These four scientists they came together in Dartmouth College, and they have proposed a project. In that project, they have proposed a 2-month 10-month study, and in that proposal, they have given the term artificial intelligence. So, the concept of artificial intelligence was there, but officially it is being launched in the year of 1956. And they told that and they proposed that whatever the problems that are existing in the society, it can be solved by artificial intelligence. So, those are the claim of these four scientists, and then the other scientists also joined them. So if we have to see the details of John McCarthy, he has developed a programming language Lisp or list processing, which was used for artificial intelligence till 1970s or 1980s. Then Simon and Newell, they are from CMU, and they are logic theorists. So basically, they were developing artificial intelligence related theorems. And then Minsky, who is the founder, not only the founder, we can say he's the co-founder of Artificial Intelligence Laboratory in MIT. So these four people, they are having very high prestige, or we can say higher importance in the field of artificial intelligence as they have started it. So this is how the field has started in 1956. So after they have proposed that we can solve all the problems through artificial intelligence, few inventions have come into the picture. Like in 1964, Elijah, the chatbot psychotherapist, and in 1966, for example, Seki, a general purpose mobile robot. So it is not like these two inventions have come into the picture. So many came into the picture, but I am just giving here the important ones. So what has happened? The artificial intelligence is termed or coined in 1956. For example, in 1964, Elijah came, 1966, Seki came. So whatever the thing they have proposed, slowly it was becoming a success. They proposed that we are able to solve all the problems of this society, and that was happening. We were getting the solution to our problems. Okay. So till this it was okay. So what we have seen in 1950, Turing test came. So this is a test to understand or to evaluate one artificial intelligence machine. If the artificial intelligence machine is passing the test, then we can say it is Turing complete. So this is a basic test which is developed by the scientist Turing. In this, one questionnaire will be there who will question to one human being and an artificial intelligence machine at the same time. So if he is unable to distinguish the answers coming from human being and the machine, then we can say that the machine passes Turing test. So this test came in 1950. Then in 1956, AI, the term AI or the field AI is being founded. Then 1964, Elijah came. 1966, Seki came. So everybody has started to think about artificial intelligence, and everybody got the belief that we can solve all our problems. And that too, the scientists they have claimed that within 10 to 20 years we will solve all the problems. So that much optimistic they were. But what happened? Once we have reached till early 70s, we have seen the first winter in artificial intelligence. So winter means since this term has come from US, So in the season winter, everything will be paused in US. So that they define the failure of artificial intelligence in the name of winter. So from 1974 to 1980, this artificial intelligence has seen its first winter. So what are the reasons? Failure of machine translation. One second. Failure of machine translation, negative results in neural nets, and poor speech understanding. So these are the important failures, or the means you can say these are the main reasons before the first fall of artificial intelligence, or the first winter in the field of artificial intelligence. Similarly, again in 1987 to 1993, this artificial intelligence field has seen its second winter, or second decline. And we can say the decline is due to the decline of Lisp, because Lisp was heavily used for artificial intelligence, or Lisp coding was used to write the different logics of artificial intelligence. So since this language is being declined, this is one of the reason for Winter 2. And then decline of specialized hardware for export systems. So in 1990s, what happened? We have seen our general purpose computers. So computers, they have started coming into the picture. So whenever we are having our personal PCs or personal computers, we can design, or these are generalized computers. You can design any kind of application from them. But what is expert system? Expert systems are dedicated or standalone systems. So since we have started using computers, which are generalized processors, so these expert systems, their advancement got declined. So that is also one reason for the second winter in artificial intelligence. So what has happened when we have reached early 90s, or early or late 90s? Simply, people have started hating this field, artificial intelligence. So till 90s, the term artificial intelligence was there with us. Slowly, using that term also means the usage of that term artificial intelligence decline. So what is the main reason? The first reason is diehard optimists. So the developers in artificial intelligence, they were diehard optimists. They told that we can solve any type of problem in the society. But once nothing workable came out for the end user, the field has started its own decline. Okay. So people are interested in products. They are not interested what are the prototypes we are making. They are interested in the product. So if we are unable to provide them their product, or if we are unable to provide the products to our investors, then they will lack their interest and they will not invest in our farm or in our ideas. So what
Suraj,
is, yes.
are you changing slides? Because slide changing is not showing here. It is
Okay, okay.
in first slide is showing.
Okay, okay.
Yes, yes,
So let me share it again.
yes, yes, yes.
So let me share the whole window, then it
Yes,
will be better. Is it visible now?
yes, sir. Make it full screen, sir. Yes, sir. From the starting.
I'm changing the
Yes, sir.
slides. Is it visible?
Now, yes, sir. Now it is visible, sir.
Okay. So I will go through the slides firstly, then I will discuss the next topic.
Yes, sir.
So I was talking about these four scientists who have officially termed artificial intelligence: John McCarthy, Simon Newell, and Minsky. They have done it in the year of 1956. McCarthy was the regent for Lisp language. Then Simon and Newell, they were from CMU and they were logic theorists. And Minsky was the founder of Artificial Intelligence Laboratory in MIT. So then I have discussed about Eliza and Secchi. So this is the image of Secchi from 1966. Then I have discussed the success of artificial intelligence and two winters. This is the first winter from 74 to 80, and this is the second winter from 87 to 93. And the reasons are being discussed by me. So what I was on this slide. So what was the reason for failure? The first one is die-hard optimists because they told that they will give all the solutions, but nothing workable came out, or end products have not come out for the end users. So that is why people have started lacking interest in artificial intelligence. So slowly, what has happened? We were having theorists who will develop the algorithm or who will prove the theory, and we were having application based scientists who will develop the applications. So AI, this field AI got sandwiched between theorists and applications. So AI was a logic based or logic driven approach. So it was unable to prove any theorem till 1990s, and ultimately it was unable to provide us some end products. So these theorists, they were not believing AI, and the people who were developing applications, they have started uh, believing in AI. So AI is being sandwiched between these two, and everybody has started hating AI, and it has happened in such a way that the people who are working in artificial intelligence, they have started calling their sub branches as main branch. For example, some people they were working in image processing. So instead of calling artificial intelligence, they have started calling their field image processing or computer vision. The people who are working in natural language processing, they have started calling their field natural language processing instead of artificial intelligence. But natural language processing, machine learning, computer vision, deep learning, all are the sub branches of artificial intelligence. And if you will see, till 2010 or 2015, we were listening all these terms. We were not listening artificial intelligence, but artificial intelligence was there. People were fearing to use that word artificial intelligence because if you are selling your product in the name of image processing, computer vision, or natural language processing, it is having a positive impact. If you are telling this product belongs to artificial intelligence, so the investors, they will think that maybe this field artificial intelligence is not success, so this product will not succeed in the future. So due to the bad name of artificial intelligence, people have left that word, or they have stopped naming their projects as artificial intelligence. But what happened again? So as I have told, these are the sub branches like machine learning, deep learning, natural language processing. So if you will see till 2010 or 2015, we were familiar with these terms, but we are not familiar with the term artificial intelligence. So till now, what we have seen, that is logical. This artificial intelligence cannot prove theorems. It was unable to provide us solutions. So we can say till now it was logical. But suddenly what happened? In 1996, EQP, which is an artificial intelligence technique, proves that Robbins algebras are all Boolean. So this is the first instance. I'm not going through details of this. So this is just the introduction to artificial intelligence. So this is the first instance when artificial intelligence or the artificial intelligent algorithms have started proving a theorem. So first time in 1996, Robbins algebra is being proven as Boolean expressions by EQP. Then what happened? We were unable to provide any solution. We are unable to provide any product for end user. But what happened in 1997? Deep Blue. So this Deep Blue is an artificial intelligence machine which ends human supremacy in chess. That means it has defeated Grandmaster Gary Kasparov. So this is not the exact picture from that competition, So in right hand side, the person is Gary Kasparov, and in left hand side picture, the machine is Deep Blue. So in 1996 also one match was held between Gary Kasparov and Deep Blue, and Gary Kasparov won that match. But again, the developers of Deep Blue, they have modified the machine and they put a competition in 1997. And in 1997, Deep Blue has defeated Gary Kasparov, and Gary Kasparov on media he has told that Deep Blue is having an intelligence level similar as human being. So this is the first instance after the failure of artificial intelligence when one product came out which can compete human being. So, and next what has happened, I'm not going to the details of this. In 1999, remote agent takes Deep Space One on a galactic ride. Then AI planner to Mars rovers in 2004 and 2009. So these are the AI planners that has been installed inside Mars rover. So what happens in case of Mars rover when rover is walking on the surface of Mars and one obstacle it faces, then it cannot decide whether it will go front or go back or right or left. So it will send a signal to the surface of Earth. So this is the problem I am facing, what to do. Then the scientists sitting on Earth, they will decide what to do and they will send the action sequence to the rover. So it was a time-taking procedure. So to avoid that, one AI planner is being installed in Mars rover in the year of 2004 and 2009. But at that time also, everybody was opposing. But the scientist who has developed this AI planner, they told that let us keep it inside the rover and we will operate the rover manually. But if sometime it is required, we can use the AI planner also. Until today, this AI planner is working fine. So this is also one success of AI. In 2005, that is DARPA Grand Challenge. So this is a challenge of automatic car race, and this is being won by Sebastian Vettel. So in 2005, we have seen that we can go for automatic car racings. Then in 2011, IBM's Watson became the winner of Jeopardy. In 16, AlphaGo became Go game winner. So this is a game where the machine won when compared to the human beings. So slowly from 1999 or we can say early 2000 till 2015, again this AI field has seen its success. It is able to prove the theorem. It is able to give us end products. So what has happened? Previously, we used to tell if it works, it is not AI. People were telling like this because of the bad name of artificial intelligence. If your algorithm is working, if your machine is working, they will tell that this is not belong to artificial intelligence because artificial intelligence cannot succeed. That is the bad name. And now we are living in an era where we are telling it is all AI. Whatever the thing we are seeing, whatever the innovations we are seeing, all are related to artificial intelligence. So slowly from here we have reached till here in a very short span. So that is why this field needs certain attention to understand it and to develop our or to solve our day-to-day problems through artificial intelligence techniques. So after seeing all this history of artificial intelligence and why it came into the picture again from 2010 or 2015 onwards, so what are the broad reasons for high demand of AI in the market and previously why it was not succeeding? So the first reason is, or the first success, or the first reason for success of present AI is better algorithms. Algorithms were there with us, and we can say better algorithms were there with us. The techniques that we are using now, like neural networks or deep neural networks, it is not like in last 5 years we have developed them. It was there, but we were unable to use them efficiently. Why? Because of more data. So whenever you are having a better algorithm like deep learning techniques, it needs very high amount of data to train the models. But if you will go before 10 years, the data or the available data for research was very less. And if you will see in last 10 years, every year you will get some standardized data sets, or you can get data through IoT. This IoT field has helped for data collection in larger extent. So now we are in a state, as much as data we need for training an algorithm, we can acquire that through IoT or any other procedures. So now better algorithms are available. We are having more data, so that requirement also fulfilled. And the next thing is more computational power. So if you want to implement certain algorithms or certain applications in users' smartphones, let us say. So before 10 years, the smartphones we were using, they are not computationally efficient. But if you will see the smartphones of nowadays or our laptops or our workstations, everything is having GPUs or more computationally efficient CPUs. So now we are able to make the work faster and efficiently. We can go for parallel processing. So all those things which was a theory in 2000 before 2010, now it is becoming success and we are able to do it. So these are the three parameters which combiningly came into the picture to make artificial intelligence a success for nowadays scenario. But these three things are important technical factors. So, what is the external factor? External factor is broad investment. If investment is not there, then we cannot develop a product efficiently. Somebody should invest in that so that we can buy more computational power, we can buy more data, you can say, and we can develop algorithms. So for R&D or research and development, we need investment. So what has happened recently? All the farms or the user-friendly farms we can see they have started investing in artificial intelligence. So for example, Google predictive search engine. So here you can say whenever we are searching in Google, if you type some word, some predictions it will show us, and that prediction is based on what we have searched in our previous few search. Okay, so according to our history, it will give us prediction. So some artificial intelligence algorithm is being used for that. So Google is using artificial intelligence, and Google is using or Google is investing to develop algorithms for that purpose. Then let us discuss the example of Facebook. So in Facebook, if we are uploading a photo, let us say group photo, and automatically you can see Facebook is suggesting or Facebook is detecting the faces of your friends, and it is suggesting or it is recognizing who is that guy, and it is suggesting whether you want to tag that friend or not. Okay, so that is the feature of Facebook auto tagging. So here the techniques face recognition from image processing, they are investing a lot in that. So Facebook is also a user-friendly investor in the field of artificial intelligence. So coming to Twitter, so when some offensive tweet is there, automatically Twitter is detecting that and it is also reportable. So to do that, Twitter is also using the artificial intelligence heavily. Similarly, we are having our chatbots like Siri, Alexa for our virtual assistant. So this is heavily dependent on speech recognition. So for that purpose, they are investing in speech recognition. Coming to the high-profile investor Tesla, they are developing the self-driving cars. So inside a self-driving car, we are having nearly all the applications of artificial intelligence, from image processing, object detection, object recognition, face recognition, everything. So coming to our OTT platforms like Netflix or YouTube or any other platforms, if you will observe it closely, in Netflix, you open your account or you open Netflix and your friend will open Netflix, the recommendations will be different. So what they are doing, they're extracting your information from Google search or your previous searches in Netflix or YouTube, and according to that, they are giving a recommended list to you. So for that purpose, they are using artificial intelligence. And according to report, it is believed that in Netflix, whatever the recommendation videos they are giving to us, 70% of those videos people are watching. So that is a report through or by Netflix. So coming to Gmail, in our Gmail we are having a spam folder, and automatically some mails are being detected as spam mails, and it is going to that folder. So how to know which mail is spam or which mail is the original? So to do so, Gmail is using artificial intelligence. So the aim of the discussion is these fields or these forms are trending forms in today's scenario. And since these firms they need the applications of artificial intelligence, so they are investing in it. Since these firms are investing heavily in artificial intelligence, so the requirement is very high. So that is why these four factors came together, we can say after 2010 heavily, and this artificial intelligence field again it is blooming. So this is all about we can say the demand for artificial intelligence. And if you will see, ImageNet is a dataset in image processing which is having thousand classes. Thousand classes means we are having thousand different type of images or different level of images. We can say like car, tree, aeroplane, birds, or anything. So it is a very big data set, we can say. And on this data set, this AlexNet, it is a convolutional neural network model or a deep learning model which is developed in the year of 2012. They have they got this is the error. They got an accuracy of 84% in the year of 2012 or 13. And if you will see, means why I am showing this table, this is what we are achieving very rapidly. So in 2012 to 13, if you see on this data set, the error was 16%, and resonate came in the year of 16 or 17, 2016 or 17, and we reached an error of 3.6%. And if you will see the present algorithms which works on ImageNet dataset, they are giving nearly 100% result. So from 2012 to 13 till 2022, we have reached from 84% to nearly 100% accuracy on ImageNet dataset. And this ImageNet dataset is treated as a very complex and a very big dataset in the field of image processing. So that's why now I will direct my discussion towards deep learning in the field of artificial intelligence. So we'll stick to deep learning. What is deep learning and why it came into the picture? So we are having traditional methods with us or handcrafted methods with us. In those methods, we were having two steps. First step is whatever the raw data we were having, we will go for feature extraction, means we are extracting the abstract information from the data. Then those data will be used to classify the raw data. Okay. For example, let us say I am having two different type of birds and I want to classify whether that bird is a crow or that bird is a peacock. So then what I will do, I will go for a feature extraction and I will extract the features of their tail. Okay, the peacock is having a very beautiful and big tail, and the crow is having a very small black tail. So if I am extracting that feature only, I can able to differentiate between a peacock and a crow. But if I am differentiating in between a cow and a crow, then my feature can be their legs. Crow is having two legs and cow is having four legs. So if that is the feature, then my classification will be very easy. So here we can say that in handcrafted methods or handcrafted techniques, the feature extraction step, it is a very important step. If you are able to extract important abstracted information from the raw data, then the classification procedure will be very easy and you will get good amount of efficiency or accuracy. But this feature extraction technique, it is not a generalized one. It depends on the type of raw data. If raw data is varying, then feature extraction will vary. Okay. So if let us say we are going for some age detection technique, some age detection technique can work well on certain amount of data and it will not work good on other type of data. So these feature extraction techniques, they we can say they are hard techniques, which are not flexible. So to avoid this, scientists or the researchers, they have proposed a technique, one end-to-end trainable model, and they proposed that instead of a separate feature extraction technique, we will go for an end-to-end trainable model where the feature extraction will also be updated along with the classification step. Okay. So simply, what is the procedure? So the procedure is I am having a raw data. I will have my desired output. Okay. So desired output, let us say D, and from raw data I am getting the output Y. Then my error will be D minus Y, and this error will be backpropagated to update the model, the classifier. So why we are doing like this? The target is the raw data should achieve or Y should be equal to D. Then only we can say that this model is fully trained. Okay. But in deep learning, what the researchers have told, we will get the error here, and this error will not only train the classifier, it will train the feature extractor too. Okay, so this error will train both. So what is the advantage? We are telling the end-to-end model that if the image is dog and its label is 1, then here my target is I should get 1. So you update the internal weights of classifier and feature extractor in such a way that if I am giving 1, I should get 1. Okay. So these two steps combiningly we are updating inside the deep learning technique. Okay. So how this technique is happening, let us go through that. And for that, I will start from the very beginning. How this step, this convolutional neural network or deep learning process that happens in image processing. So for example, I am having two images with me. One is, we can say, the silhouette of Apple logo, and in right hand side, I am having a white color cross on a black color background. So if I will show this image to a non-image processing guy, his answer will be this. This is one Apple logo and this is one white color cross on black color background. But if I will show this image to an image processing engineer, what he will see, he will not perceive this image as a white color cross on a black color background. So what that guy will perceive? That guy will perceive this image is nothing but a grid-like structure. And if the grid or one cell contains black color, that means its value is, for simplicity, 0. If the cell is having a color white, then let us say the value is 1. So an image processing engineer can perceive one image as a matrix. So from image, we have shifted to a matrix form, and once we have converted to a matrix form, then we are having matrix related applications or matrix related theorems and formulae with us, so that we can apply different formulations and we can solve the matrix. So once we will reach here, what we can do, this image we can put into the classifier as a feature. So how one image is being given to a classifier? It will be given as a vector. So this is a 3, 6, 9. This is a 9 cross 9 image. If I want to give this image for classification, what I have to do? I have to convert this image into a vector, one dimensional vector. So that one dimensional vector can be a form of 1 cross 81. That means this is column 1, this is column 2, column 3, column 4, and so on. What I will do, I will concatenate C1, then C2, then C3, and so on, and I will make a one dimensional feature. So that process I have shown here, and the process is known as flattening. So this is a 2 cross 2 plus 2 channel image, and if we are having RGB image, then we are having 3 channels. So here, for example, a 2 cross 2 cross 2 image is being shown, and if we are flattening it, then we will get the values like this: a D cross 1 vector or 1 cross D vector, anything we can say. And once we will convert the image into a vector form, then we can give this to, let us say, our neural network. So here we are having 8 number of nodes, 8 number of data, and in neural network we will have 8 number of nodes, so that point to point matching can be done. And then this neural network or feed forward network will be used to provide us the classification score. Okay. So I'm not discussing about neural network. We are more interested in deep neural network or convolutional neural network. So this is the process of flattening. When we are doing image processing, first we have to go for flattening, and then we can feed that flattened vector into a fully connected feed forward network. So for example, I am having one image which is of size 227 cross 227 cross 3. So if I will flatten this image, I will get a matrix of, a vector of 1,54,587 cross 1. So whenever I will feed this one into a neural network, fully connected neural network, I need this many number of input nodes. So the neural network should have 1,54,587 number of input nodes, and each node or each connecting link will have its own weights, which will be updated throughout the training. So that means the number of parameters are very high, because I am using the whole image as a feature vector. So what the researchers have observed, they have observed that whenever we are giving one image as input, for example, I am taking this patch and this patch, we can see that this patch and this patch, they are nearly same, or there is not much information in that. So this patch and this patch, they are quietly different. But whenever we are going for image processing, we will have number of patches which are similar, or the information is repeating. So they told that instead of going for full image for 1 lakh 50 for 587 number of uh, image pixels or image vector, we should go for a filtering technique or Cornell technique. We will take a simple image patch, we will multiply it with a Cornell, and we will get the output. So instead of getting 1 lakh 54 587 number of what is that parameters, now I will have a either 3 cross 3, that means 9 parameter, or 5 cross 5 kernel, 25 parameter, 9 cross 9, and so on. Any one we can use according to our application. So this number of parameters can be reduced to 9 or 25 or 81. But what is the problem? How to choose this filter? So they told that, the researchers told that if you are taking a single kernel, then it may happen that your information is, or you are losing some information. So since this is an arbitrary procedure, instead of taking a single kernel, this procedure you repeat for number of times. So instead of having a single kernel, I will have, let us say I will take 96 number of 3 cross 3 kernel. So now my parameter will be 96 into 9. And then also we are having very less number of parameters compared to 1 lakh 54 587. So this is the procedure, and since this kernel we are shifting from position to position and then we are multiplying it with the original image, this procedure is similar to convolution. So whenever this block is added to the overall neural network, it is known as a convolutional neural network. So the neural network, which is having this step or this layer inside it, where we are just filtering the image, and these kernels, they are not fixed. During the process of training, we are updating this kernel in such a way that we will get our desired output. So this is how the convolutional neural network has been born. So what we have seen in the previous slide that I have represented here, if I am having a 6 cross 6 image, for example, how one filter or one kernel works on it. So let us say I am having a 3 cross 3 kernel. So that kernel will be applied on first 3 cross 3 elements of the image, and it is a point-wise multiplication. And after adding them, I will get my first value. So that will be 3. So next, that kernel I have to shift row wise or column wise, and I will calculate the next value. So similarly, I can calculate all the pixel values for one image. Okay, so here what is happening? We are sharing the weight. Previously, total image will be converted to a vector, then that many number of weights we need in neural network. But now we are sharing our weight over the kernel. Same weights are applied for this window, same weights are applied for this window too. So we are applying or we are sharing the weight. So weight sharing concept was advantageous in case of convolutional neural network. So since we have started discussing about convolutional neural network, what are the different layers it is having? In neural network, we were having fully connected layers. So now two different type of layers have been added to the overall network. One is convolution layer, and another one is pooling layer. In convolution layer, we will have either 2D kernel or 3D kernel. So whatever the thing you have seen here, this is a 2D kernel. If I will go for a 3D kernel, if my image is a color image or RGB image, then I can go for a 3D kernel, 3 cross 3 cross 3. Okay. Or if I am working on video signal processing and I am having number of frames, then I can go for 3D kernel. So this is the procedure of or what happens inside convolutional layer. So here, what we are doing, we are going for filtering. So filtering means, let us say age detection is one type of filtering. So in convolution layers, we will get the abstracted information. So from my image, raw image in convolutional layer, I am getting abstracted information. And then what I will do in pooling layer, slowly I will reduce the size of the image. Okay, so that my final image vector will be very less compared to the initial one. So that is the work of pooling layer. So how one convolution layer works, that I have explained previously. We will have a kernel, it will be multiplied or it will be convoluted with the original image and we will get the output image. Then we will go for the pooling so that the original image will be downsampled. So what is the advantage? It reduces the dimension of feature space. Then translation invariant. Convergence rate of max pooling is faster compared to average pooling. So that is why we are using max pooling in means max pooling generally used in most of the cases. So how this pooling happens? So for me, this is a 8 cross 8 image and it is being converted to a 4 cross 4 image after max pooling. So in max pooling, what will happen? We will select a window. Here the window is selected as a 4 cross 4 window. So I am choosing this much. Then I am having 4 pixels in that. What is the maximum value of the pixel? That will be chosen and it will be placed here. Maximum value. Then I am having the next one, and what is the maximum value from that 4 pixels, and it will be placed here. So by that, one new image I can create whose size will be half of the original image. And if the procedure is like this, that means I am having a stride of 2. Stride 2 means I am jumping 2 places in a single operation. So first I was taking this one. If next I will take this window, then stride is 1. If first I was taking this one, then the initial point is jumping 2 places from here to here, 2 places. So stride is 2. Stride is 3 means if the initial position is here, next I have to come to here. So that is the concept of stride. So now coming to the whole CNN, we were having the input image, then we are having convolution layers and pooling layers, and this convolution and pooling layers, they will be repeated multiple times. Then whatever the final image we will get, or a very small abstracted image we will get, that will be flattened and we will get a feature vector from the image, and that feature vector will be fed to fully connected network. And this whole procedure is an end-to-end trainable model. So every parameter can be trained throughout this training. So this is all about the whole CNN. And coming to one example of CNN, this is the AlexNet network, which I have given in previous slide, which was being developed in the year of 2012 or 13. In AlexNet, we were having 5 convolution layers and 3 fully connected layers. And you can see in each convolution layer, we are having convolution layer. It is having a filter of size something, and what is the stride, and number of channel means how many convals you are using. Then whether it is a max pool or it is a average pooling. So the details are like this. It is a 5 convolution and 3 fully connected layer network, AlexNet. And if you will see the outputs from AlexNet, so I'm giving one hand gesture image to it. And in first layer, you can see I'm having 96 channels. Here I have shown 96 channels. So from a single image, I will get 96 different type of images. And you can see that in some images, I am getting the age. In some images, I am getting the silhouette. And in some outputs, I am getting the texture of the image. So all different type of abstracted informations will slowly be learned by the deep learned network. So this is the first convolution layer. So what is happening after first convolution layer? If you'll see the further convolution layer outputs, you can see the information is slowly being abstract, and finally we'll get a very small image, and that will be flattened to give us a feature vector, and which will be fed to the feed forward network. So this is the process of convolutional neural network on image processing. So these CNN techniques can be used on any type of object recognition, object detection techniques. Here I have given the example of hand gesture image, but it can be used for any application related to image processing. So this is how image processing can be benefited from CNN, or in terms of deep learning, or in terms of artificial intelligence. So here, whenever we are training one image processing model, if the data is not sufficient, two techniques are there. One is transfer learning and one is data augmentation. So what is transfer learning? Let us say this AlexNet network is there with me. This network is there with me. So this is the representation of AlexNet network. So instead of starting a new network or new model from scratch or from zero, I will start from here. So already this AlexNet is being trained on ImageNet dataset. So if I want to use a network like AlexNet, I will not start from the beginning. I will not initialize the model weights. I will start from already trained network, and then from there on, I will start my new training. So what is the advantage? Whenever the training data is not sufficient, then this transfer learning technique will be helpful. Okay. So we can reduce the problem of overfitting. So what do we mean by overfitting? If the training error is, or we can say, whenever we are training a model, the error is reaching near to zero. But when we are applying our testing data, our error is not reaching to zero. So let me give a small graph. Let us say when I am training one model, so this is the loss and this is the training loss. And whenever I am giving the testing data, the data which is not used for training, so this is my testing loss. So if this gap, what is the target? I have trained a model. Now I am expecting that my testing data will perform well too. But if the testing loss is more compared to training loss, we can say that our model is overfitted. With training data, it is working fine, but when new data it is facing, it is unable to detect or recognize it. So to avoid this situation, we can go for transfer learning. Similarly, data augmentation technique means if our data size is very less, we can translate the data, rotate the data, or reflect the data to virtually increase the size of the data set. So we are introducing some variables in the data set and we are increasing the data set. So now in each iteration, my algorithm will see the same data in a different form. So if this is the original image, here a rotated form and here a flipped form, the algorithm is showing. So I can say that virtually I am increasing the data set. So this is how data augmentation technique works. So this is all about the image processing. Coming to video processing, in video processing we can use the LSTM networks or long short-term memory networks in deep learned models. So LSTM means long short-term memory. So here in this type of networks, what we will have in video processing, I am having a collection of images. One video means it is a set of images, set of frames. So frame to frame, I am having some relation. If this is the first frame and this is the second frame, this is the third frame, there is some temporal relationship from here to here and here to here. So we have to model that. So in LSTM, what we are having? We are having three gates. One is forget gate, one is input gate, and one is output gate. Forget gate means it will forget or the amount that will be forgotten in the next iteration. Okay, so for example, I'm distinguishing some text and I'm saying uh, any example we can give. The color or mango is yellow. So here it is, the information is saved, mango is yellow. In next step, let us say we are telling the potato is gray. Okay. So this yellow should be forgotten, this mango should be forgotten, and potato and gray should be saved into the network, and this word is should be there. So what the network will forget? The network will forget mango, the network will forget yellow, but is will be remembered. The new data like potato and gray will be input to the network. So this forget gate, this helps to forget some information, and this input gate help us to update the cell state. So this is the cell state, update the cell state, and then output gate, it provides us the next output. So this is how a LSTM network works, and it works for sequential network. So same procedure, instead of convolutional neural network, we will have sequential network where we can give any type of feature and it will calculate or it will give us the relation between frame to frame. Okay, for example, I'm having a human action video and I will take few frames from that, and what is the relation among those frames. So if I can model that relation, I can distinguish what type of action it is. Okay. So what I am doing, I will take a pre-trained network, then I will put those frames into it and I will calculate the feature. Okay, so this feature will be deep features for me, deep features. Then these features will be fed to LSTM network to model it or to model the temporal relationship among the action frames or the video frames. So this is how one deep learning network or convolutional neural network along with LSTM can be used for video signal processing. So these are the applications of human action recognition, like surveillance, observing patients in hospitals, then in video retrieval, sports video analysis, human computer interaction, and so on. So similarly, this deep learning techniques can be used for speech recognition, which is a part of our artificial intelligence technique also, where we can use these speech recognition techniques in the field of automotive, where speech recognizers can improve driver safety by enabling voice-activated navigation systems. Then in technology, virtual assistants like our Siri or Alexa. Then in healthcare and sales. In sales, you can see that so many chatbots they are developing. In any marketing site you visit, you will get speech recognition technology through chatbots. So this is in speech recognition, how this AI got its advantage from IoT that I have discussed. So the main reason behind combining AI with IoT is, while IoT devices serve the purpose of collecting all the data and transferring it to usually cloud or any other space where data can be accumulated through the internet. AI is what actually helps in decision making and simulating the machines to act or respond. So now we are in a scenario where artificial intelligence and IoT they are working side by side to give us a end product. So that is what we can conclude, or what is the application of AI in IoT, or what is the application of IoT in AI. They are working simultaneously to give or to provide us end products. So if we are seeing AI with IoT. The applications are traffic management, self-driving cars, smart homes, body sensors, robots for manufacturing industries, face detection, retail analytics, smart buildings, and so on. So again, before concluding this session, I am coming to from where we have started, why the demand of AI is so high in the market. Due to this, we are having better algorithms. We have seen that we are having deep learning algorithms for image processing, video processing, then speech recognition, and IoT. Then through IoT, we got more data, which was the prime requirement for artificial intelligence. And we are having more computational power nowadays. And more importantly, we are having investors who are investing for artificial intelligence. So due to this, the present market is very high in the direction of artificial intelligence. So with this, I can conclude this session, and this is all from my side. Thank you.
Thank you, sir, for a nice presentation, which was very informative and which will be very helpful to the researchers and students which are who are eager to work in this field. Now, I request the audience if they have any questions, they can ask. They can ask. Dr. Shaw. Yes, yes, Avik.
Thank you. Thank you, Ravi. Yes. Yes. In which field? It is plentifully available. Nowadays, the problem in dataset is not there, what I think. You can download any data from internet. That yes, yes. Yes, that you have to search actually. Why I am telling, because I have not worked in that field, so I'm not having idea where to download those data. But what I think, you can go for any survey papers, okay, recent survey papers in which you can get the information regarding the data sets and the links to download them. Exactly from which place you can get those data sets. That you can go for. Yeah. Welcome.
Okay, now I'm asking Dr. Shalpa Kumar Roy. Are you there, Dr. Shalpa Kumar Roy?
Yes, I am there.
Yes, yes, yes. So I actually personally invited you. So do you have any question here? Please.
No, I have seen actually very little bit of presentations, but
Yes.
it's so nicely presents for the beginner as well as the future perspective, which is
Yes.
Thank you.
nicely given. And actually, I don't have questions.
Yes, yes, yes. So
Then,
actually,
then I'm saved there.
yes,
Yeah, no,
yes,
no. Actually, yes. If it is means you are given totally from the baseline,
Yeah.
and if it is problematic, then I might have some questions.
Yes,
So
yes.
yes, yeah. Actually, I have started learning deep learning from 2016.
Okay.
Actually, Suraj, I know you, right? So
Um,
Dr. Deepak Kumar Ghosh.
yes, yes.
So that time
He was my lab.
we have a conversations, I think.
Oh, maybe I have forgotten.
Yeah, Shomi Darida is your supervisor, as
Yes, yes,
yeah,
yes.
as Deepak I have, right?
Actually, this talk I have designed in a very generalized way so
No, no, that
that
is good.
who are not working in this field also they can get some motivation.
Yeah, fine. That is
Otherwise, it will be a technical talk, pure technical talk.
yes, yes, yeah. That is fine. Means it should understand the layman, right?
Yes, yes.
So I think it's good. And
okay,
if we have some question, we can later discuss.
Yes,
okay.
we can
Uh,
talk personally also.
Yeah, yeah, yeah.
any other question from the audience? Do you have any other question? Because
Yes, sir.
yes, yes, Alok, please.
Hello, Suraj sir. This was a very nice presentation, and
Thank you.
yeah, this was very well prepared and well presented. And
Yes.
I personally, been deeply, moved by the presentation. Thank you so much for that. And I have a concern of the shortcomings of image processing in products, in real-time products.
Yeah.
Let's say, for example, you have talked about autopilot, self-driving cars.
Yes.
According to the U.S. Department of Transportation, uh, since 2018, there have been 11 accident cases, which means there have been crashes of Tesla cars which were running in autopilot mode,
Yes.
and which led to 17 injuries with one death.
Yes.
So how do you answer, like to support the shortcomings of image processing in self-driving cars?
Yes. If Tesla car is facing some accident, means that is a failure of image processing engineers, not the Tesla car owner. So it is a challenge, because why I am telling, we can't say Tesla car has failed. We can say our techniques have failed, and the image processing R&D section, which not only image processing, Tesla car is having so much sensors in it. So they should take the feedback, and again they should do on that, because what happens, so many engineers or so many researchers, they are working day and night to develop, but maybe it is not reaching to them. So it is the responsibility of the development section of Tesla car. If they are facing like this, they should search for the solution. And we can't say this is this automatic cars or some automated systems. They are means like disadvantages to our society. Since our society is moving in an automated way, we can expect that. But at the same time, it should not create any problem for the society. If 11 accidents have happened, that is not good for the society. They should come up with a solution.
Don't you think? Yeah, thank you so much.
Yes.
Don't you think this is early or somewhere wrong to uh, go for uh, AI with image processing, which actually includes human lives?
Yes.
What's your take on that?
See, whenever you will start, we will face this type of situations. Whenever we will start, because whenever your products are not going to the real time scenarios, you cannot check them. First of all, and before launching the product, we should verify it in artificial real time scenarios. And I hope they have done that, but they have failed. According to you, if 11 accidents have happened, that means it is a failure to the system. So they can go for that again. Means they should analyze why these accidents have happened. And now, for your case, which techniques are being developed? Like they are mixing different blockchain algorithms with the automatic cars. And what is the advantage? Let us say the car got accident, so we can't say whose failure is it. Let us say this is the failure of the developer, or somebody has created some third-party software, and due to that, some accidents have happened. So to prevent data loss, or to prevent any data, what you can tell, if someone is trying to change the data, these blockchain technologies, they can be used, and everybody will be a decentralized network, and data will be transparent to all, so that by incorporating those techniques with artificial intelligence, definitely they will come up with certain solutions in near future. That is my expectation from Tesla.
Thank you so much.
Yes, well.
Okay, Suraj sir, I
Yes,
actually personally have one question.
yes,
So actually, what I have seen that this deep learning, machine learning, AI algorithms are powerful. Okay, when we are doing
yes,
the in 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 processors like using the Python, MATLAB in computers. Okay, now
yes,
basically this organizer is a hardware perspective we think. Okay, so I my
yes,
point of view always is a hardware point of view. So
yes.
recently, I was working on an algorithm called spiking neural network. Though I am a very, I do not know very much about machine learning algorithm. So what I have seen that in that case, in some neural network, the weights are accumulated when we are
Yes,
training. Okay, training.
yes,
Suppose for a digit recognition problem, we are training the algorithm for 1,000 images, or 1,000 images, or 10,000 images, 6,000 images.
yes,
What I observe that the weights are keep increasing. Suppose initially they are at the range of 100, and
yes.
then they are going to range of 1,000, 10,000, 1 lakh. Okay. So,
No, no, sorry for interrupting.
yes,
The number of weights are increasing or the value of weights are
value
increasing?
value of the
Okay,
weights are increasing. So
yes,
we can deal this problem in the MATLAB or Python we can deal with, but in
yes.
case of hardware we cannot deal such type of irregularities, I mean say continuously increasing. So how to handle this kind of problem, if you can suggest?
Yes, actually, means again, if that is the scenario, I have to also check that. But
Yes.
what is the theoretical aspect to it? Means what I know. Generally, we can go for some. See, weight means what? We are having some nonlinear functions, and
Yes.
weights are a part of that.
Yes.
Okay. So in neural network, whenever we are using those weights, with that we are using some other nonlinear functions like hyperbolic functions, tan hyperbolic functions, sigmoid functions, which will bring them into certain range. Like tan hyperbolic or sigmoid means it will bring those values inside 0 to 1, and this is not for algorithm, this is for hardware implementation, because whenever we are thinking about hardware, those values should be limited.
Yes, of course.
So that is why these concepts have come into the picture. And if you will see the example that I have shown you, so many ReLU units are there, rectified linear units. Its work is to means what you can say, it acts as a threshold. If the value is increasing certain limit, then bring it down.
In the negative part.
Negative and positive part too.
Yeah. Mhm.
So now, if we scale down, I have scaled down that. Now, what I've seen that performance degradation is there.
Yes, yes, definitely. If you are degrading that, then again your performance will be hampered. But this training is an iterative way. So whenever same thing you will do it again, and the trends the weights will be trained in such a way that we will reach to the desired data. So always reaching to or exactly desired data is not possible, but we can reach up to the desired data. So that is the goal.
Yes,
So,
yes.
so in hardware means let us say we are going for the hardware, we can adjust a little in the performance, but our hardware performance should be good. Instead of 100%, we can get one accuracy of 99.9%, but it should be fast enough for the end user. That is the first goal. Otherwise, the user cannot click a photo and wait for one day to get a solution. So it should be very fast enough.
Yes, yes, yes. Thank you, sir. Anybody have any question? Gautam, sir, do you have any question?
Sir, are you there? Or you are also like my students?
I have no question. It is clear and it is
Okay, sir.
good.
Okay, okay.
Okay.
So if audience has no questions, so we can conclude this session, and hopefully in the next time we'll back with another webinar on similar topic. So uh, so we can conclude this webinar. Thank you all. Thank you,
And,
Suraj Prakash
and
sir.
from my side, this is a very good initiative by the team.
Excuse
And
me,
I
sir.
personally,
Yes,
yes,
yes, yes. You can ask any
Uh,
question.
can I ask a question, sir, please?
Yes,
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 Sir, I am sir. My name is Shivabrat Rath, and I am from
yes,
NIT Rourkela, sir.
yes,
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 And I want to ask a question, sir. That recently Nvidia has launched their RTX cards, right? I mean, new graphics cards.
yes,
They have implemented several amount of AIs. I mean, in artificial intelligence in image processing lines and thermal lines and whatever they have, sir. Right, sir? But
okay,
sir, in the scenario, if we talk about the mobile section, if we talk about the mobile GPUs,
yes,
lot of mobile GPUs like Mali GPUs and Adreno GPUs, they do not have these functionalities in them,
yes, definitely.
uh, so that they can have a better amount of image processing. We can say better thermal functions. We can say. So can we implement any amount of AI, artificial intelligence techniques to reduce down the heat as we have seen or heard about the news of OnePlus, they are blasting like anything, and all 2 to 3 cases are there. So these,
See, okay. So let me come to the question.
so
So basically, the smartphone is not designed for what we can say training of some model.
yes, sir.
Okay. So whatever the training part, we can keep it to our high computational end, like workstations or whatever GPU installed device you are having. So that is the first target, and smartphones are there to only use those high-end softwares.
Yes, sir.
Okay, that was the target. But if I will tell why you are playing a very high complex game or high requirement, sorry, high CPU requirement game in your mobile, you can say why not? Okay, so that is why we have shifted to mobile phones, and since your smartphones are in your hand, so people are more interested in that, and slowly its RAM size and its complexity have increased. But since we know that if we are going for very high complex machine, it needs means it needs proper cooling, and it should have the ability to sustain those algorithms. Okay, which a smartphone, which a today's smartphone is not having. We cannot say what will happen tomorrow, so till now, we can keep our training part to workstations or high-end machines, and testing part can be kept to mobile phones, which can be done. Okay. So if we will try to execute all the things in a smartphone, so it will be a little difficult as of today.
Okay,
But
sir.
we may hope that tomorrow we
So,
can get very good quality smartphones, we can
so,
which can handle all those problems.
so
Yes,
thank you, sir.
welcome.
okay. Thank you, sir. I think anyone having any question? Okay. So we can conclude this session, and we will soon will come with another webinar. Thank you, sir. Thank you.
Welcome, and
Thank
thank
you.
you to the group for inviting me, and
Yes, sir.
I'm very much grateful for that also.
Yes, yes.
Okay.
Thank you, sir. Thank you, sir.